Hi friends, welcome to Krishang Talks. How are you all doing friends? I hope you all are doing great. In today's video, we are going to discuss about the Newton's laws of motion. So Newton's laws of motion are the laws that define the motion of an object. And it also defines the reason for why the object moves and for what reason the object moves. So the first Newton's law of motion is that a body will be in the state of rest or will be in the state of uniform motion unless or until it is acted by a force. So let's take an example. When you roll a ball, it goes on like that and stops for some time. Why does it stop? It stops because a frictional force is acting on it. If the force does not act, it will go on like that with the same uniform velocity it has been given. So at this time no force is acting on it, right? And it's moving in uniform velocity. And now let's take an object and it is in rest. Unless you try to move it, it will be in rest. Let it be for eternities also. It will be in rest. So this is about the first law. And now let's talk about the second law. The second law is the derivation of force. So the formula is F is equal to the rate of change in momentum with respect to time. It can be represented as dp by dt. That means change in momentum by change in time. Momentum is nothing but the mass into the velocity. It is the momentum. So dp can be written as p final minus p initial, and it can be written as m into v minus u by t final minus t initial. So this is the formula. So if you want an acceleration, v minus u by t is the acceleration. So it will be changed as ma. So F is equal to mass into acceleration. But acceleration directly depends upon the force and it inversely depends upon the mass. This is about the Newton's second law of motion. So the Newton's third law of motion is that when you apply a force on some object, it will apply an equal and opposite force. So for let's say you try to push a wall. When you try to push a wall, the wall tries to push your hand. So that's why the wall is stationary. So this is the concept of Newton's third law. So let's take an example of Newton's third law. When you walk, you try to push the ground in the backward direction, and the ground pushes you in the forward direction, thus making you move. So friction is very important in our life, and the force which pushes your leg forward is the frictional force. Force is very important in our life. Now let's talk about the free body diagram of bodies. The free body diagram is nothing but when you consider the object as a point and you draw all the forces acting on it. For example, let's consider a normal block lying on a surface. So there are two forces acting on it. The gravitational force acted by the earth on the block and the normal force which is exerted by the surface on the block. The normal force is the type of contact force in which the surface it acts on the block. So there are two forces acting on this block. So tensional force. Tension force is a force in which when a string acts on it, the string has a tension force. And this tension always acts to the opposite direction of the body. For example, when you hang a block from the ceiling, tension force acts upwards, which is equal to the downwards, which is equal to the downwards gravitational force. So this is about the normal force and tension force.